On page 11-3, we are going to be looking at what happens when there are variables under the square root sign. So there's going to be a couple of different ways I go through it. The first way will be the formal way that they show you up above here in the notes, and then I'll kind of just go through a way you can kind of think about it as well, if that makes more sense to you. So you're going to either have where your exponent is a multiple of 2, so an even number. So one thing to realize is that the square root, all right, we know that we don't have to write the 2 with the radical sign, but what that means is you actually have am to the 1/2 power. So the square root is actually an exponent of 1/2. So if you remember back from Unit 6, we multiply our exponents. So this is really a to the m divided by 2, or times 1/2, however you want to think about that. So if your exponent is an even number, the way you simplify it is that you take half of it, because it's technically an exponent of 1/2. If it's not a multiple of 2, then what you do, and I know this looks really confusing, but you just take 1 away. So let's say that your m was 9. That means you would split it into 8 and 1. All right, that's all it is, and then you would break it apart from there, that you'll see down below. So that's kind of the formal way to do it. So I'll show you the formal way, and then I'll show you a little bit less formal way. So I'm just going to do the odd problems on this video, and then I will do the even problems on another video. So number 1, all this is you have an even number, so you do x to the 2 divided by 2, which is 1, so x to the first, but we don't need to write the 1, so just x is your answer. You do not need to show this step. Hopefully you can just do 2 divided by 2 in your head and know that that is 1. Number 3, we already have an odd exponent. So I'm going to go through the formal way first. I'm going to split this box into 2, and I'll do the formal way on the left-hand side and then the informal way on the right-hand side. So the formal way is to split this into n to the 4th times n to the 1st. Okay, you don't need to write the 1, but you can if you want. If you want to skip that step and go right to this, square root of n to the 4th times square root of n, you can do that. So this one becomes n to the 4 divided by 2, which is just 2. So if you need to do the step where you write out 4 divided by 2, you can do that. And then the square root of n just comes along. You should not have any exponents underneath the square root sign. That should always just be a 1 under there. So that's the formal way, or what I call the long way. What I do is I just ask myself, how many times, and I'll write it out, how many times does 2 go into 5? So that's the first question you ask. How many times does 2 go into 5? Well, that would be twice. So that's where the n squared comes from. So when you say twice, that's where this exponent comes from. And then you need to say what's left, or how many's left. That would be 1. So the 1 has to go under the square root. You should always only have 1 left for what we're doing. Eventually in Algebra 2 you'll get into different exponents, so then you might have more left, but for everything we do, you should not have an exponent underneath. All right, so the formal way is to show it all. The informal way is to ask yourself, how many times does 2 go into 5? That would be twice. So that goes on the outside, and then there's 1 left over underneath the square root sign. So if I do it the formal way for number 5, 25 is a perfect square. So if it's a perfect square, you're going to put it under your first square root. 6 is a even number, 13 is not. So we need to make it go down to 12, and then 1 left over in its own square root. So that's how you split it apart, doing the formal way that it shows above. Anything that is a perfect square, so 25, goes in your first set, and then your even exponents go in the second, or in the first set as well, and then your leftover goes in the second set. Square root of 25 is 5. 6 divided by 2 is 3. 12 divided by 2 is 6. That's where our exponents come from, again, is that you divide by 2. And then your square root of y just comes along. So I'm not going to write it out a second time, but if you just ask yourself, square root of 25 gives you 5. 2 goes into 6 3 times. That's where that 3 comes in. 2 goes into 13 6 times with 1 left over. So you put the 6 for your exponent and then the 1 left over y under the square root. You didn't have any leftover x's, so that's why there's no x under the square root. Number 7 gets a little bit trickier because 63 is not a perfect square, so you have to use what we learned in our first set of notes to break down 63. So 63 would get broken into 9 times 7. So the formal way to do this is to put a square root. The 9 goes in your first square root, your 7 goes in your second square root. B has an even exponent, so that whole thing goes in your first square root. So the only thing that should be in your first square root are perfect squares and then even exponents. Square root of 9 is 3. 2 divided by 2 is 1. So 3b is on the outside and then square root of 7. For number 9, we obviously have the 8 along the outside, so I'm going to bring that down. 320, maybe you know that 4 goes in, but that's not a big enough perfect square, so you need to find your biggest perfect square that goes in there. It would be 64. So 64 goes in your first square root. It's 64 times 5, so 5 goes in your second square root. X does not have an even exponent, and it's only a 1, so it goes there. Y to the 4th is an even exponent, so it goes in your first square root. Bring your 8 down, times square root of 64 is 8. Y to the second, again you do 4 divided by 2. That's how I get my 2 for my exponent. Square root of 5x comes along. So our final answer is 64y squared square root of 5x. And number 11. 128 is not a perfect square, so you need to find the biggest perfect square that goes in. Again, it's 64, so you're going to have 2 square root signs. 64 times 2. So put your perfect square in your first square root, and then whatever you need to multiply to get back to your regular number in the second square root. P to the 5th means I would have 4 here and 1 here. Q squared would all go here, and R to the 18th would also all go there. Square root of 64 is 8. 4 divided by 2 is 2. 2 divided by 2 is 1, but again we don't need to write the 1. 18 divided by 2 is 9. So 8p squared, q to the 1st, r to the 9th is on the outside, and then the square root of 2p. So that's the formal way to do that. If I were to just do this on my own, I would do the 128 separately. So I would do the 64 and the 2, square root, square root. So I know I have 8 and the square root of 2 somewhere. Then I would go back and do this part on its own. How many times does 2 go into 5? Twice, with 1 left over. So I write p squared on the outside and then a p on the inside. How many times does 2 go into 2? Once. So that's where my q comes in. How many times does 2 go into 18? 9. So r to the 9 with none left over. So if you feel more comfortable just asking yourself that way, that's how you could skip the whole formal part. You still need to know how to break down the plain numbers though, and then figure out your exponents as well. Again, I know this is very confusing, So make sure you watch both sets of videos and then ask questions.